Okay, so now I'm going to show you how to solve compound inequalities. Now, we're going to work with two types of inequalities. One is going to be like this, where you have an expression trapped between two numbers, and then another one is going to be inequalities that actually give you two separate inequalities, like we did down here. So we're going to look at both types of those. And so let's start with the first type, where you have an expression kind of trapped between two numbers. So what I want to do here, when you have this, it's kind of playing the old game monkey in the middle. You want to isolate the x in the middle. So you want to try to take this expression and eliminate everything but the x. So what you would have to do that is, you'll notice here there's a 2x plus 3. So the first thing we want to do is subtract 3 from the three sides. I'm going to call it three sides. So even though it doesn't make sense, but here's a side, here's a side, and here's a side. So to keep this inequality balanced, I'm going to subtract a 3 from each of these. So I'm going to take minus 6 minus 3. I'm going to take 2x plus 3 minus 3. And of course the reason I'm doing that is so that these two will cancel out. And then I'm going to take 7 minus 3. Well, now all I have in the middle is 2x. And then on the outside I have minus 6 minus 3 is negative 9. And then 7 minus 3 is 4. So now I have 2x trapped in the middle. And so now all I have to do to isolate the x is just divide the middle by 2, and if I divide the middle by 2, then I have to divide the two outside regions by 2. And so when I do that, then of course 2 divided by 2 cancels, and I just get x in the middle, and then on the outside I get negative 9/2 here and positive 2 there. So that's going to give me x is greater than negative 9/2 and x is less than 2. And the interval notation for that would be negative 9/2 comma 2 with parentheses. Okay, over here is another one, and basically I'm going to start the same way here as I did over here. I want to get rid of this 3, so I'm going to subtract 3 from the middle so that the 3 will cancel with that 3 there, so the 3 and the minus 3 will cancel. And then of course if I subtract 3 in the middle, I've got to subtract 3 on the left. Minus 7 minus 3 is going to give me negative 10, and then I got to subtract 3 on the right, so minus 3 gives me negative 6. Well, now I have minus x in the middle. Now in order for me to change that from minus x to x, I need to multiply that by negative 1. So remember, I have to multiply this by negative 1. And if I multiply that by negative 1, then of course I have to multiply the negative 6 by negative 1, and I have to multiply the negative 10 by negative 1. Okay, but remember what happens when you multiply an inequality by a negative number. The signs must reverse direction. So notice here, when I get down here, I get negative 1 times negative 10 is 10, but remember the sign changes from less than or equal to greater than or equal to. And then of course minus x times minus 1 is x. And then here the sign changes from less than to greater than. And then negative 6 times negative 1 is 6. So I get 10 is trapped between, x is trapped between 6 and 10 sort of. But generally when we represent an inequality like this, we always want the smallest number written first. So what I'm going to do is I'm going to read this from the smallest number to the largest number from right to left. And just watch what I do. If I read from right to left, this says 6 is less than x. So that's what I'm going to write here. 6 is less than x. And x is less than or equal to 10. And so here I write x is less than or equal to 10. So that way I can turn it around and I get my inequalities right. So now the interval notation for that, since 6 is not included, we put parentheses there. And since 10 is included, we put a bracket there. and then it would be everything between 6 and 10, including the 10 but not including the 6. Okay, so now let's take a look at when I give you two inequalities like this. Now, or is like a union. When I say or, it's a union. Okay, so here I have 3x minus 1 is less than 0. And then if I want to solve that, so I can add 1 to both sides. So if I add 1 to both sides, I get 3x is less than 1. And then divide both sides by 3, and I get x is less than 1/3. So one solution is x is less than 1/3. Now, let's solve the other one. 2x minus 1 is 5, so add 1 to both sides, and I get 2x is greater than 6. And then divide both sides by 2, and I get x is greater than 3. So the other solution is x is greater than 3. So what this tells me is that the solution set is all values, represents all values less than 1/3, so that would be this region in interval notation, union with all values greater than 3, so that would be this set. So it's everything less than 1/3 plus everything greater than 3 is the solution set. All right, let's do another one. This one is similar. This one here is similar. So if I want to solve the first inequality, just add 6 to both sides, and I get x is less than negative 13 plus 6. So x is less than negative 7. Okay. Now, the next one, if I divide both sides by 6, I get x is less than or equal to negative 10. So x is less than or equal to negative 10. Okay. Now, since this has an or, what it means is it means we must include everything that's in either one set or the other set. Okay, everything that's either in one set or the other set. Okay, so let me go back to this. I had to make a correction there, but if you look at the number line, take a look down here. Negative 7 would be everything from negative 7 to the left. And x is less than or equal to negative 10 would be everything from negative 10 to the left. Since this says or, then you must include all values. So which one of these would include all the values, here and here? It would be, if you include everything less than negative 7, that would actually include this region. So actually, the answer would be x is less than negative 7, or negative infinity to negative 7 would be the solution set. So anyway, I hope that made sense to you. When you see the and, it usually means the intersection of two sets. So on this problem, I have minus 6 plus v is greater than or equal to 0. All I have to do here is add 6 to both sides, and that'll give me v is greater than or equal to 6. And then on this one, all I have to do is divide both sides by 2, and that'll give me v is greater than 2. Okay, so now it's everything that's greater than or equal to 6 and everything greater than 2. Well, if you think about that, if we said everything greater than 2, that would be from 2 on out here. Okay, and then if we said 6 greater than or equal to 6, that would be 6 there and on out. Okay, but the and tells me I want the intersection. So look and see, where do these two sets intersect? And they actually don't intersect until you get there at 6. So they intersect from 6 to infinity. So the solution, when you put those two together as an intersection, is the set from 6 to infinity. And of course you're including the 6 with the bracket. Okay, so here's another one where you've got this expression here in the middle. So what I'm going to do here is I'm going to subtract 8 from all three sides. So I'm going to say minus 4 minus 8 here. And then, of course, if I subtract 8 from 8 minus 3m, the 8's will cancel, and I'll just get minus 3m. And then I'm going to subtract 8 from here, and 11 minus 8. So that's going to give me minus 12 is less than negative 3m is less than or equal to 3. Now, to solve this, I've got to divide everybody by -3, right? So divide everybody by -3, and let's see what happens. Okay, so -12 divided by -3, that's 4. -3m divided by -3, that's just m. And then 3 divided by -3 is -1. But remember, since I divided everything in this inequality by a negative, the inequality flips over. So the less than here becomes a greater than, and the less than or equal to becomes a greater than or equal to. So now I have 4 is greater than m is greater than or equal to -1. Now again, we want to write the smallest number first, so read it from right to left, and it reads -1 is less than or equal to m is less than 4. So let's write it in that direction, and that way we have the smallest number on the left. And in interval notation, that would be with the bracket on the -1, comma 4 with the parentheses on the 4. -1's included and the 4 is not included. Okay, this next one is an OR again, but we've got two inequalities here. Now I did this one I did this in my head, so hopefully you can see what I did here. So to solve this, all I did was I subtracted 3n from both sides. So I took 3n away here, and then I took 3n away here, and that's how I got the n over here. And then of course the 3n's canceled there. And then I subtracted 8 here, and then I subtracted 8 here, and these 8's canceled, and I got -6 minus 8 gave me -14. So that one's n is less than -14. Now the next one, I subtract 9n from both sides. So take 9n away here and 9n away here, and I get n on the left. And then I add 8 to both sides, so add 8 there, and then add 8 there, and I get 17 on the right. So I get n is greater than or equal to 17. Now, what you want to do, since this is the union of two sets, this is everything less than -14. Okay, I don't know where the 15 came from. I guess I typed it wrong. But it's everything less than -14. So it would be -infinity to -14. And then everything greater than or equal to 17. So it would be union the set bracket 17 to infinity. Again, that should be 14 instead of, that should be -14 instead of -15. So I just punched the wrong key. Okay, I'll do one more, but notice this one says and. So this is where the two sets intersect. So let me just do this one real quick. Okay, let's say I subtract 10x from both sides. I think you can maybe follow along now. Subtract 10x from both sides, and it'll cancel the 10x and give me -8x over here. Then if I subtract 9 from both sides, it'll cancel the 9 and give me a -8 over here. And then if I divide both sides by -8, the inequality flips over, and I get x is less than or equal to 1. Well then, the next one says 3x minus 2 is greater than or equal to 7x plus 2. So if I subtract 7x from both sides, I'll get -4x over here. And then if I add 2 to both sides, I'll get 4 over here. And then if I divide both sides by -4, the inequality flips over, and I get x is less than or equal to -1. So let's see if I got the right answer. I want the intersection of x is less than 1. So let's say that's x is less than or equal to 1. And then x is less than or equal to -1 would be right here, right? So it'd be farther over to the left, right? So that would be the region x is less than or equal to 1. That's the region x is less than or equal to -1. Where they intersect would be everything to the left or equal to -1. So the solution would simply be -infinity up to and including -1. So that would be the final solution set. Now I've got one more video for this section, and it deals with absolute value inequalities. And so that will finish up this entire chapter 2 that I've created here.